Woo, woo.
Okay, I like that. Woo, woo. Okay, so let's start with, I'm going to give you the priority list of the of the functional groups, organic chemistry. And I'm going to add a couple of them on there and we'll go over them. So we have at the very bottom right now, we have, so I had told you guys, I don't know if I told you guys, I can't correct it, but when you have this guy, can you guys name the structure?
Is that alcohol?
Not an alcohol, nope.
That's
Isn't it like an alkene?
alkane. What octane?
So it's an alkane. So give me the name of the alkane. How many carbons does it have?
5.
Four.
4.
It has 4 carbons.
Oh,
Count them. 1, 2, 3, 4, and it has Cl at the end of it. Okay, so actually that's wrong. Let me count it right so that you don't make that mistake. 1, 2, 3, 4. Okay, and so this guy would be, has 4 carbons. So what is a 4 carbon? What is the prefix for 4 carbons?
Bute.
That's right, bute. So it's butane. The functional group?
One chloro?
Chloro.
Or not?
That's right, 1-chlorobutane. Oops. Good job. Okay, so these guys are actually called halo alkanes. And they're the lowest part of the functional group. I think I had said alkaline halides. Alkaline halides is actually a double bond O attached to a carbon and a halide. So I wanted to clarify that. Then we have alkane, ether. Ether is going to be a new group that we talk about today. Then we have the alkane. Then we have the alkyne. Then we have the alkene. Come on. So above the alkene, we have the amine. Then we have the alcohol. We have ketone. We have the aldehyde. So I should probably underline this guy. So ketone, but in a different color. Maybe, nope. Aldehyde. And the carboxylic acid. So these are the ones that we're going to be going over. So today we're going to be going over the carboxylic acid, the aldehyde, the ketone, and the ether. Okay, so I see there's a question. Okay. So Destiny asked the lowest part of what? So this is basically the priority list. So when we look at the functional groups, it lets us know where it stands in terms of the priority list, how we're going to name it. So like, for instance, we named this guy, if I remember, 1-chloro butane, right? So we know that this guy is a halo alkane, and you notice it ends with ane, and then the halogen we drop to an O and put it on there. Okay. So the first one we're going to start off with is, let's do esters. I mean, not esters, ethers. Okay, so ethers, there's two ways of naming ether. One way is more commonly used, one way is less used. The prefix for your ether is going to be oxy. And then typically it has an ane at the end. So the functional group for ethers, I'm going to go ahead and erase this now. Or the ether R represents hydrocarbons. So an ether basically has hydrocarbon on one side, hydrocarbon on the other side, and an oxygen in the middle. And so if we have this guy, the way we would go about naming it, there's two ways. You want to find the longest carbon chain. 1, 2, 3, 4. And we know that this guy is just 1. So then we would call this guy methyl oxy butane. So that would be one way of naming it. The more common way of naming it is calling it, sorry, not methyl, methoxy butane. And then the most common way of naming it is methyl butyl ether. Does that make sense?
Yeah.
Okay. So if I have this guy, what would we call that guy?
Is that eta? 1, 2, 3,
Or pentaoxy?
1, 2, 3, 4. Or it has 4 carbons in the beginning, right? 1, 2, 3.
1, 2, 3, 4. That's correct.
Is it
And on the other side,
butyl?
The octane?
2, 3, 4, 5, 6, 7, 8. Okay, so then what would I call this guy? What are the two different ways of naming it?
Would it be pencil non-named? Okay.
So Pentyl. Is it but? Are you sure it's pentyl?
Butane.
Oxyl?
Okay,
Yeah.
you said butyl. Butyl.
Oxy?
Mm,
If we're going to use the oxy way, it would be bute, buta, or bute, and then oxy, and then what is this? You said it's 8. Somebody said it earlier.
Octane.
octane.
So that would be one way of naming it. Or butyl. And what would we call an 8 oxygen? I mean, 8 carbon, not an 8 oxygen, 8 carbon.
Octo.
Octyl. Ether. Actually, let me fix this.
Can you lift it?
Oh, sorry. Sure.
Thanks.
Okay. Let's see. Let's try another one.
Dr. Henry, Brianna had a question. She said, where is butyl coming from again?
Because we know that a 4-carbon chain, 1, 2, 3, 4, is called bute. The YL just means that it's all single bonds, right? Otherwise, it'll be ENYL, and it's a side chain off of the oxygen. So that's where the butyl comes from.
Would you write those on the side for us?
You guys don't have it memorized yet?
No.
Isn't it?
Thank you.
Dr. Henry?
Yep.
What is the relevance of learning this? Is it just like for ingredient purposes on things that we're going to use? Like, say
Yeah,
if we're
so
going to the medical field?
if you're going into the medical field, a lot of drugs are named like methyloxybutane, right?
Mhm.
So you'll run across a lot of these drugs in life, like methamphetamines, right?
Mhm.
So in that case, if you don't know how to name them, you're not able to recognize the active ingredients on them, then you may not be having a job by the end of the month. You understand? So the relevance of nomenclature is so you'll be able to understand the actual chemical names of things. Because often in the medical field, you will get the generic name, but you will also have a chemical name that's associated with it. And you need to be able to distinguish that.
Okay.
It's kind of like me saying, okay, so I come to class and I don't know any of your guys' name the whole time that I'm here, right?
Okay.
So there's relevance. Don't
Yeah, I
fight
was
it.
just trying to because I asked some of my colleagues that are registered nurses and they don't even remember nomenclature at all.
Well, but at this point, it's because they've also been using it so consistently, right? And there's typically, okay, so let me put it like this. There's a lot of ways of looking at it. It also depends on the type of nurse that you are, right? And what atmosphere you're working in, right? So if you're just a day-to-day nurse where you're just taking care of patients and cleaning up poop, then, you know, you may not need it.
Mhm.
But if you want to actually go up in rank and actually excel and want to be like one that is administering drugs, then you may need it, right?
Okay.
And so there's a hierarchy in nursing, you know, and so if you want to stay at the entry level, fine, don't learn it, right? Just take the whatever grade you're going to get out of this class, right? But if you want to move up, you want to make sure that you're at the top of your game.
Right.
And I've talked to a lot of nurses that'll tell you otherwise, because it can end up with a lot of trouble if you're not familiar with what you're giving patients,
Okay.
such as death. We had an example this weekend. My grandmother, one of the nurses that came in, and she had noticed that my grandmother had another drug added onto the things that she was taking. And she read it, and she was like, okay, read the chemical name, and she recognized that it is inhibitor of calcium pumps. And she's like, Mrs. Les, aren't you already taking blood pressure medicine? Because that's what it's typically used for. And my grandma says, yeah, she says, I have 2 pills already. And my granny couldn't remember the names. And the nurse went back and took a look. The nurse not paid attention to the drug that she had administered. She had actually given my grandmother the wrong drug. She shouldn't have had that drug. And so the doctor had given my grandmother the prescription of someone else. And had that nurse not done her job and known nomenclature, then it would have been an issue.
Okay, that makes sense.
could
Yeah, I
have
was
been.
just trying to put the application process part like together in my head, but then I was saying maybe it would come at a later time, because sometimes like we learn like the general or the beginning parts of
Yeah.
things, and then later on in some other classes it starts to make sense because it starts to get put together more.
And particularly, I mean, some of the general things, sodium chloride and stuff like that, you're going to be exposed to generally. Saline solution is just salt, right?
Right.
And so we get those names, and again, we get in habits because we do things so frequently that we are doing nomenclature, but we don't even recognize it because we're doing it so frequent, And so this is just getting you prepared for that case.
Okay. Thanks.
Okay. So let me give you guys another one. Let's see. I should just tell you what my mom used to tell me, because I told you so. That's why.
You need to know it. That's it.
Yeah. Okay. Okay, so you guys got that one? Then I'll put another one. Then I'll tell you how to do that one. Okay, so let's do the pink one over here. This guy. Can you guys see it?
Yes.
Are you writing on the board? Because I don't see anything.
I'm not writing anything. I'm waiting for you guys to say something.
Oh,
I'm not
okay.
giving you answers. You're supposed to give me answers. You guys forgot the rule. I'm here to look cute. You guys are to do the work.
Okay, we're doing the one on the right bottom.
Yes.
Okay.
Is it?
So it has
I heard. What did I hear?
Is the
You start counting from right to left.
1, 2,
Two.
3, 4, 5.
Okay,
Is it ethyl, pentyl, ether?
2 on the other side.
okay. So you said. So we have ethyl. Pentyl. Ether.
Ether. Mm-hmm.
Okay, that is correct. What is the other way I can name it?
Pentyl. No, is it
Aaron wrote it in the comments. Pentaoxethane. That's what she put.
Okay, but in this case, it's the one that has the longest chain that you're going to use for the naming.
Okay, so
Okay, so that gets the last name. So would it be pentyloxethane or would it be
it oxy?
oxypentane? You see the difference, Aaron? See if I can spell.
Are we putting the smaller number in front?
Yeah, because
Okay.
remember, the last name always goes to the longest chain, right? So who's most important? The longer chain is more important in this case. So the 5-chain carbon is more important than the 2-chain carbon. So you always want to put that last, right? So that's why we always count to figure out who has the longer chain. Does that make sense?
Yes.
Yeah.
Okay, so in this case, I'm going to actually do this one for you. This is just for. I'm going to put it up here. So, but you guys have to tell me some things though. What is the longest chain?
where are we at?
Up here.
Oh, the longest one is the one on the left. Yeah, this 1, 2, 1, 2, 3, 4,
6?
5, 6, 7.
7. Okay.
The other one's 2,
Okay.
and then we have it spliced or up there at the 4.
Okay. So then we have side chains. 2 side chains up here.
Mhm.
These side chains are going to be what?
On the 4. So
They're going to be ene?
Are they going to be?
No.
Methyl,
They're going to be methyls. Okay.
Yeah.
So the way that I would do this here.
dimethyl,
Dimethyl. That's right. Dimethyl. So it's 4
with
4
7.
dimethyl. Oops, 4.
Hepta.
Heptane.
Heptane, yeah, heptane.
We have. Oops. And then this guy, a 2 carbon chain.
2 chain.
Is ether?
ethyl,
So it'd be ethoxy. Oops. Ethoxy or 4 dimethyl heptane. Or
Dimethyl.
oops.
Why is it 2 4s?
Just 2 chains going off of 4.
Oh, okay.
That little V looking thing.
So if it would be one little chain, then it's just 1 4. But because it has 2 chains, then it's 2 4s.
That's
Yeah.
right. There's 2,
Okay.
1, 2. two methyl groups hanging off of it.
Or okay. Thank you.
So, or it would be ethyl or for dimethyl butyl ether. Oops, not butyl, heptyl, sorry. Ether. And then often, put this in. Okay. And use the parentheses to let it know that it belongs to the heptyl.
Dr. Henry, can we do another example where we have like another side chain?
Sure.
Can we clear part of the screen?
Yes, that's what I'm doing right now.
Thanks. Dr. Henry, are you teaching phys at all? Do you know by now?
If I'm teaching physiology
Yeah.
In the fall,
Yeah.
typically I don't know if I'm teaching physiology until the very last minute.
Oh.
I mean, it's literally like a week before the class starts.
Okay.
So, and that's usually because somebody either got sick or something happened.
Are you still going to teach in heart now?
I don't know because everything is going face to face, back to face to face. So I don't know. I don't know yet.
It's just so exciting that everything's normalizing again.
Yeah, it is. And I'm excited, right? But right now it's like I feel like there's still so much stuff that's up in the air
Yeah.
that I'm still trying to figure it all out. Okay.
Dr. Henry, we count from inside in, right? Or inside to
Inside
out?
out.
Yep, inside out. So you start at the O.
I get kind of confused sometimes because I feel like sometimes it starts off a little sooner than at the point, if that makes sense.
No, because the O this is a bond between the O and the carbon. So literally it's like this.
Okay.
Okay, so that's what that represents. So that first carbon is,
Starts right there.
yeah, oops. Okay,
Okay.
so what am I going to do?
Number them. So we have 5 on the left and 3 on the right.
1, 2, 3, 4, 5. So that would be our longest chain.
Yeah.
And then on the right we have,
I think that's
3.
3. Is
Okay.
this split just going on to the top?
1, 2, 3.
Yeah.
Wow.
Okay. So what is this guy gonna be called?
2-pentyl.
Set 2,
2-ethyl.
2-ethyl.
I thought it was gonna be dimethyl.
Nope. Why would it be dimethyl? Because that's 2 chains that are connected to each other. If it was 2 independent chains like this, then that would be a dimethyl.
Oh, okay. Okay. I see.
Oops. Okay, so we have 2-ethyl. Somebody said.
Mhm.
Would you finish
Five-
making that
A
side?
five chain carbon is called
Penta. Penta.
Okay.
okay.
Um,
On the other side, what do we have there?
2-methyl.
2-methyl.
Propyl. Yeah.
Oops. 2-methyl propyl. 2-ethyl pentyl
Ether.
ether. Or oops, I'm going to borrow this. Two methyl propoxy, 2-ethyl pentane. I have a tendency of using the ether because it's easier to remember for me.
Mhm.
Both of them are acceptable. Both of them are used. Questions, concerns, Cash? Okay, good. Okay, so the next one we're going to talk about is ketones. So a ketone looks like this, generally. Where this is a carbon double bonded to an oxygen. So C. And then on each side you have hydrocarbons. And so the way that you would count it is you want to count the longest chain, including that carbon, and then you use the number to tell where the double bond is located. So for instance,
So want to count the longest chain, then use double bond to tell the location.
You use the number to tell the location of the double bond.
Use the number.
Okay. The suffix for ketones is O-N-E. Okay. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8. So an 8-chain carbon is called
Octa.
so it'll be called octanone.
Oh, okay.
And then we put 2 in front to let us know that the double bond is located there. Okay, questions? Okay, no questions? Good. So if I have this guy,
Ketone. 1, 2, 3. 1, 2, 3. 6. So you're gonna have 5.
5
We need
non-known.
No, no,
Nona known or
no
no?
one.
that's right.
Known.
Nona known.
Nona, known.
No, no.
Horrible name.
Sounds like a gnome name. No known.
Okay. Simple.
Yeah.
So if I have,
Wait, where do we get that A from? Or is it just like a spacer?
it's like a spacer.
Okay.
Okay. If I have a double bond here, what would this guy be called?
2 hexone. Hexone.
1, 2, 3, 4, 5, 6. So you said hex.
1, 2.
Yeah.
So 2
2 hexone.
hex. Now what
Hexanone.
about that double bond? How do I handle that double bond?
Oh.
Mm,
Is it like propane?
It's not gonna be an. It's gonna change.
Could be an Y-N-E, ein.
Oh, it'll be an E and E, right? Double bond.
E.
Yeah, think about the alphabet. A, single bond. E,
oh,
double bond. Y, triple bond. Okay, so those are your 2 possibilities. Nasty, eh?
Hex E.
Okay, ready for your next one?
Yeah, a new one besides ketone.
Yep.
Okay, let's go.
Oh wait, Brianna pointed out something in the chat. I think you forgot to replace the E, I think, in the double bond.
I forgot to place the E.
It's the 3N is reflective and then 2-one, as opposed to the 3-enone.
Oh, I see. Okay.
There's two different ways to write it.
Yeah. So I didn't forget to place the E. I just, the E and E means it's a double bond, right? As the A and E means it's a single bond. I mean, the AN means a single bond. The EN means a double bond. Does that make sense, Brianna? Single.
She's still stuck on it.
Am I?
She is.
Double. Double bond right here.
She's good.
Okay. Let's see. Oops. And okay, so the next one is aldehydes. So aldehydes are also going to have a double bond connected to the oxygen. That's our functional group, and it's going to have an H. So this is a terminal, it's called a terminal functional group, meaning that it's typically at an end. So it looks something like this.
Like formaldehyde.
Yes, like formaldehyde. Actually, formaldehyde is just 2 hydrogens. Okay, so this guy would be called, this is your first carbon. This is your second carbon. This is your third carbon. So a 3-carbon chain is called?
Pro.
Okay, so this guy would be called propanal.
Propanol.
Not all,
Al.
but al, yes.
Propanol.
Aldehydes.
Oh. Aldehyde.
Okay. So okay, what would that guy be called?
Let's see. 1, 2, 3, 5, 6, 7, 8, 9 carbons.
Okay.
So Nona. No now. But we have those other things on there.
Okay, so we have no now.
No. No. And then 6.
Dihexyl.
6 dimethyl.
So how many methyl groups do I have hanging off?
3.
I have 3. Yes. So that's
Trimethyl.
1,
One
2, 3. So it would be
trimethyl.
where's the location?
6,
6.
6, 7.
And 7. 6, 6, 7.
True. True.
Trimethyl. No, now.
No.
Okay. Questions, concerns, Cash? So if I throw a double bond in there,
Mhm.
what would that guy be called?
Let's see. 1, 2, 3. 1, 2, 3, 4, 5, 6.
Hexanol.
Yeah,
Okay.
hexanal. And well, could it be?
So would it be hexanal?
Could it be hex dash
Hexanol.
4? Hex dash 4 dash.
Would it be 4 or would it be
3.
3?
it would be 3? 3 hexanal.
Yeah, I'm
Right.
sorry, I was looking the other way. Yeah.
Or you could do it the way that you were looking at it. Hex. 3.
And
Could you raise it? 3.
Al.
Okay. Questions, concerns, Cash?
I can't see. Sorry, the bottom.
Sorry. There you go.
Oh yeah, hex 3 and now.
Okay. So our last one is carboxylic acid. Okay, these guys look like this. Okay, an example. This guy would be called, and the prefix for it is oic acid. Three carbon chain, 1, 2, 3. What do we name a 3 carbon chain?
Pro.
Pro.
So, propanoic
Propanoic.
acid.
Propanoic. So this is a prefix one. It doesn't have a suffix.
No, it doesn't.
I'm sorry. Did you say what aldehyde and ketones were?
Yes, I did.
Must have missed
Ketones
it.
only has suffix.
Okay.
It's ON, ONE.
Okay.
And aldehydes.
Aldehyde.
The
AL.
aldehydes are only, they'll have AL.
Prefix, right? Where are we at? Aldehyde. No. Suffix. Okay.
Okay. Oops. I copied the same thing twice. Hold on, let me go back to this. Oh man. And actually, let me give you correct. So ketones was ONE, was the suffix. They do have a prefix, it's OXO, where
Okay.
this one is OXY. The aldehydes, the suffix is formal. I mean, the prefix is formal, and then the suffix is al. And then for carboxylic acids, it's carboxy. And then it's oic acid.
Oic acid is a suffix.
Yep.
Okay.
Okay. So if we have this guy here, 2, 3, 4, 5, 6. Okay. What's that guy? Longest carbon chain?
Is
Six.
Heptanoic acid.
8 octa.
7.
Oh, 7.
7. That's right.
Hepta.
So heptanoic acid.
That is correct. Simple?
Yeah.
Mm.
Kind of.
Okay. Okay, so those are your hydrocarbons. Let's give you guys a quick rundown. Let's see. You're not yawning.
I
Oh,
know.
wow.
You got me yawning. Did that grant get passed?
No, I won't know until the summer,
Oh,
actually September-ish. Hopefully it did, and
yeah.
that'll be so good.
And the building you mentioned for West Hills, what's going to go in it?
All of our classrooms, so it's going to be a pretty big building, 2-story building, and it's a 2-story and science labs are going to be on the second floor. And then the other classrooms, it's going to be kind of like, oh, you guys probably don't know. So I taught it to Larry. So it's going to be kind of like the building that's to Larry. So it's going to occupy the space where the faculty offices are.
Right on
in
the
the
left.
front. Yeah. So we're getting ready to those front two buildings pretty much. And then also the back building. So all the buildings over there, the science building, all of those are going to be destroyed and everything.
Oh wow.
Yeah. And then of course you guys know that Fireball is also getting their new building. It's currently being built.
Wow.
So, and I become responsible for the labs.
You're gonna get your name on something like the rose bush bench or something?
Nah, nothing like that.
They'll put your name on a plaque or something. Watch. Dr. Henry space.
Oops. And
Oh, those are all separate, huh? You want us to like identify each different one?
one, two, three, four, five. Okay. These are all different structures here. What I'd like you guys to do is tell me the family they belong to. I'll put letters by them here in a second. Separate it so we can actually write. And then also the name it's of that particular one. Or the functional group it belongs to and the name. I'm missing something here. No yawning.
Oh, it's contagious.
Come on. There we go. This is A, this is B, this is C, this is D, this is F, G, H, and I, J. Okay. So, first one, A. What family? What functional group?
Carboxylic acid.
Carboxylic acid.
Is it the haloalkane?
No, A is carboxylic acid. Haloalkanes must have a halogen. Halogens are fluorine, chlorine, bromine. So, okay.
Halo.
Okay.
Okay, so what would be the name of this guy?
Of B.
No.
Would it be
Of A.
aldehyde?
Oh,
The actual name of it.
so 1, 2, Pentonic acid. No, not pentonic acid.
Pentanoic. Okay. And then it has what attached to it?
A methyl?
It has a methyl. So the methyl's on 1,
Two.
2, 3 on the
Three.
carbon
The third.
chain. Yep. 3-methyl pentanoic acid. Okay. Okay, B. What family?
An aldehyde.
Okay. The name?
But-
So,
Propanol, propanol.
1, 2, 3, 4. 4 carbons.
So it's butane,
Butanol.
butanol,
Butanol. Okay.
You don't know.
dimethyl.
Okay. Where's the where are the methyls located? 1, 2,
On the second.
3.
1,
Two,
2,
on the
3,
third. On the
Three.
third.
3, 3.
Di.
Dimethyl.
Dimethyl. Okay. See the family?
Dr. Henry, for our exam this week, is it going to be like primarily nomenclature?
It's going to be mostly nomenclature with a little bit of everything else, with seasoning of everything else.
Okay, thank you.
Spicy.
So C belongs to what family?
Is it a carbolic acid?
Nope.
Alcohol?
Because remember, carboxylic acid has an OH and a double bond O.
Alcohol? Okay, gotcha.
It's an alcohol. That's right. Okay. And I remember alcohol because the O, you know, alcohol, OH. in there.
OH.
Yep.
Nice.
Okay, so what would be the name of this guy? Oops.
4-pentanol?
You do. Hold on. There you go.
Or wait, 1, 2.
So you said 1, 2, 3, 4. Let's say 1, 2, 3, 4, 5. So 4-pentanol. Would it be 4-pentanol?
Or would it be 2-pentanol?
It would be 2 because remember you want the lowest number.
Yeah, lowest number. Yeah.
Okay. So D.
Is that a
Family?
ketone?
Ketone. That's right.
You're missing a letter? A, B, C, D, E.
Yeah, I'm missing E. Can't do my alphabet. Struggling.
It's all right.
Rough day. Okay. So how am I going to name my ketone?
So 2, 1, 2, 3, 4, 5.
Pentanone?
Known?
So pentanone. And somebody said 2-pentanone.
Yeah.
2. Okay. F.
Amine.
That's right. And amine. And the name.
is
Trimethyl.
one.
I like that. Somebody said try what?
Triethyl.
Triethyl.
Amine.
Triethylamine. That's right. Good job. Okay. G.
Is that an alkene?
Alkene.
Oh, I forgot one. Huh? Put it on there. Add one more. So it's an alkene.
Mm-hmm.
Okay.
So.
So what would we call this guy?
1, 5.
So you said 1, 5.
Octene.
Oops, 5. So 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
Octene. Is it octene or
Oh, sorry. I always forget the di.
octadiene?
I always forget. Octadiene.
Job. Okay. Let me add one more over here.
That could be your E.
Yeah, this will be my E. Thank you. See, I didn't forget a letter. I just forgot the structure. Okay. H.
Alkyne.
Alkyne.
Okay.
So 1. Wait, 1, 2, 3, 4, 5, 6, 7. Right? 7.
That's right.
Mhm. 7 is hept.
You said hept.
Heptine.
Okay. Okay. I.
You.
Oh, your
Alkyne.
haloalkane.
Alloalkane. Okay.
So 2-chloropropane.
2-chloropropane. J.
Oh my goodness. 1, 2.
Then alkane.
An alkane. Okay.
Or propyl.
So 4-propyl.
Yeah. 5,5-dimethyl.
5,5-dimethyl.
Mm-hmm.
Nonane.
Nonane.
question really quick on that.
Yep.
So, yeah, does propyl go after dimethyl?
Yep.
Because of alphabetical, right?
Yep. You
Okay.
can do it alphabetically, yes.
Okay.
That's the way it's, well, that's the way it's supposed to be. Alphabetically.
Okay.
Okay. The E.
Ether.
Is this how the exam's gonna look?
Yep.
Really? Is it gonna be
Correct.
more complicated?
Do you want it to be more? Do
I
you want it
don't.
to be? Do you
I
want it to be
don't.
more complicated?
No, that's why I mean, inquiring minds want to know.
Can you make it simple?
No, we're talking.
I'm like, this is kind of fun as is.
Okay, last name. Come on, come on.
Oh, ether. E.
What was it?
1, 2, 3, 4. 4 is
1, 2, 3. There's no
One.
4.
sorry. 1, 2, 3 is pro.
Propyl.
Propyl.
And what is the other side? How many carbons on the other side?
2.
Two.
And what do
Two.
I call that?
Ethyl. Or
Ethyl. That's right. Ether.
Ethyl. Propyl. Ether.
Okay. Questions, concerns, cash, credit.
The other way to write that is it ethoxypropane?
That's right.
Okay.
Write it above here. Okay. Concerns? Good. Okay. So I know we have class, it stops at 7, and we typically go to the lab. I'm going to take about 5 or 10 of your minutes, if you don't mind.
Okay.
And then we can stop. Okay. Oops.
Dr. Henry, so we're having lab on Thursday, right?
Yeah,
Can you just say what we need again, please?
sure. You're going to need, I'll let you write it up on the board.
Okay, thanks. Because I kind of joined a little, when you had already mentioned it.
5 balloons, 5 empty water bottles, you're going to need baking soda. You're going to need vinegar. Spell. Vinegar and you're going to need your measuring cups.
Measuring cups.
And spoons.
Does the size of the balloons matter?
I like to get the 9-inch ones if you're getting around, or you can get the curly ones if you want to do curly.
How dry do the empty water bottles need to be?
You want it to be pretty dry because you're going to do chemical reactions in it.
Okay, thank you.
Okay.
So this was we're doing this lab during your office hours on Thursday.
Yeah. Okay, so everybody got it?
Yes.
Okay. And let me share my screen. Okay. Let's see. Oops.
That's right, Destiny. No class today for lab.
Okay, so let's say we have the chemical sodium nitrate, right? First thing that we want to do is make sure that we have the chemical formula, right? Sodium has a +1 charge, nitrate has a -1 charge. It has to balance out. So how many sodiums do I have here?
1.
Okay. How many nitrogens do I have here?
1.
I want to say 1.
Okay. And then how many oxygens?
3.
Okay. So that makes up our chemical formula, right? So we know that there's 1 sodium. I can get this to work. Okay. 1 sodium, 1 nitrogen, and 3 oxygens, right?
Right.
So how many molecules or how many atoms of each element are in the formula unit of ammonium carbonate?
Oh, we
what
just
is
looked
it-
at.
What is ammonium carbonate?
Okay, let me look at the poly. Is it on the poly? Ammonia.
4.
Yeah, +4.
I heard somebody say
Carbonate.
NH4.
Okay, carbonate CO3, 2 negative.
Okay. So what is the charge on ammonium?
Positive.
Okay. So then how many ammoniums will I need? Will I need to balance out that -2 charge on carbonate?
2.
Okay. So how many carbons, how many nitrogens do I have?
2.
How many hydrogens?
8.
How many carbons?
1.
1.
How many oxygens?
3.
Okay. So once we have the chemical formula and we're sure that it's correct, we can sit there and calculate how many of each of those atoms that we actually have. Now, this is going to be important when we want to start talking about mass. So the way that we calculate the mass of a compound is by adding the mass of each of the individual atoms that are in that compound. So we have nitrogen. How many nitrogens do we have?
2.
So we get the mass of that element from the periodic table.
Okay.
So what is the mass of nitrogen from its atomic mass?
4.
I heard somebody say it. I wasn't sure. Say it again, please.
14.
14.
14. That's right. Okay. So we know that nitrogen weighs 14 and its atomic mass units, since we're talking about it on the atomic level, AMU. Okay. So 2 times 14 is what?
28.
Okay. Oxygen weighs, hydrogen
15.
weighs,
So hydrogen 1. Yeah.
okay. And 8 times 1?
8.
8.
Carbon
12.
weighs 12.
12.
And you said oxygen weighs
15.
15?
16.
16.
16.
16. Rounding.
Yeah, you got to work on that rounding there, right?
I do.
15.99999 isn't
It's not.
Isn't it supposed to be 12?
oxygen?
The C, the carbon.
Carbon
It
is
says 1 times 12.
Thank you. Good eye. I was testing you.
He's tired. He's ready to go. It's beer
It's been
30.
a long day, and I've been in meetings, and meetings make everything worse.
Heck
Like,
yeah. Meetings about meetings.
Exactly.
Pointless.
Okay, so then we add it together. Oops. Okay, so it'll be 96 AMU. Simple?
Yeah.
Yeah.
Okay,
Yeah.
and so that gives us what we call the formula mass for this compound. Now, as a chemist, we are interested in the difference between formula mass and molecular mass. Formula mass is basically, it's going to be taking the average of the two compounds, let's say since they're ions, right? And we know that ions are positive and negatively charged. And so basically the way that they're interacting is by that positive and negative charge. So it's not like they're fully connected. Whereas something like carbon dioxide, CO2, is connected to each other because they're sharing electrons, okay? And so, but the way that we calculate the formula mass is going to be exactly the same way as we calculate the molecular mass, okay? But chemists like to pay a little more attention to the semantic. Just for the record. Okay. Okay, so here we have sodium chloride. So we know that sodium chloride is NaCl. Sodium has a +1 charge, Cl has a -1 charge, perfectly balanced, so there's no charge overall. So when we calculate the mass for sodium chloride, what is it going to be?
23 plus 35, which is 58.
So 23 plus 35.
35, or yeah. So 58.
Oops.
AMU.
Okay, now, again, we're talking about looking at things at an atomic level. Do you guys get one thing of sodium and one thing of chloride when you put salt on your taco or on your meal, your
No.
meat?
No.
Probably put a whole bunch of salt, right? So
Yes.
for us, that one AMU is really, really small. So we need it in something that we can actually relate to and that we can use, some type of mass that we're familiar with. So what we also use is grams per mole. So I'm going to introduce you to the term mole. This is the abbreviation, and it's really spelled M-O-L-E, like the mole in the ground or the mole on your face, right? Well, a mole is kind of like a dozen. How many things are in a dozen?
12.
Okay. It doesn't have 12 things. So I could have a dozen of eggs. I could have a dozen of shoes. I could have a dozen of husbands. I could have a dozen of wives. I could have a dozen of kids, right? Dozen can pertain to anything, right? It's not dedicated just to donuts. You guys can talk.
Molecular number. Molecular number.
Yeah, so it's a quantity, right? So it basically serves as a quantity. We know that 1 dozen equals 12 of whatever we're looking at, right? So a mole is very similar to a dozen. The only thing it is 1 mole is going to be equal to
1 dozen.
6.022 times 10 to the 23rd.
Isn't that Avogadro's number?
That is correct.
Okay.
Yes. Yes. And it's Avogadro's number, right? And I'm going to misspell his name.
Does that say 22 or 23?
6.022.
6.022 times 10 to the 23. Okay, so Avogadro's number, a lot of people will say Avogadro's number because that's how they remember it. Avogadro's number is 6.022 times 10 to the 23rd, and it represents a quantity, right? So it's not a mass, it's a quantity. So when we look at the molar mass, that term, molar mass,
Grams. Molar mass.
molar mass makes reference to grams per mole. So we're comparing moles to a mass, okay?
Okay.
So in the case of sodium chloride would also weigh 58 grams per mole. So that allows us to have mass related to quantity, okay? One more thing. Okay, so when we talk about carbon dioxide, here's a carbon dioxide molecule. Okay, we have 2 oxygens represented here by the red, and we have the carbon in the middle. So we added up 16 plus 16 plus 12, 44 AMU, atomic mass units, or 44 grams per mole. Now, the numbers that you get from your periodic table, you're never going to use to sit there and calculate the number of significant figures, because those numbers are, we round them often, 44 grams per mole. And so they've also been rounded. So depending on your periodic table, they may be rounded to a different point than another place, okay? So you never want to use those for rounding or for your sig figs. Okay, questions, concerns, Josh? Okay, this is the last thing and then we'll stop. Okay, so calculate the formula mass of ammonium nitrate. First thing that we need to do is do what?
Need to write down what ammonium nitrate is.
Yeah. Okay, so what is ammonium nitrate?
Ammonium is NH4 plus.
Okay. And nitrate?
Is NO3.
Negative.
Okay, now when they come together, Heather, do they have a charge?
NO4 plus 1. No, they're fine. They're balanced.
They're balanced. Perfect. Okay, so they're written this way. Okay, so how many nitrogens do I have?
Yeah.
One.
I have 1 nitrogen?
Yeah, 2.
Or two.
Oh.
Two nitrogens. Okay. How many hydrogens?
4.
4.
How many oxygens?
3.
Okay. So nitrogen weighs
14.
Yeah.
2 times 14.
28.
Hydrogen weighs
1 times 4 equals 4.
and oxygen
16 times 3, 48.
So 80.
48.
So if I ask you for the formula mass, you're going to give me AMU or U, units. Or if I ask you for the molar mass, you're going to give me 80 grams per mole.
Yeah.
Okay. Simple?
Simple.
Okay, so
So basically it's just the same thing. The formula mass and the molar mass is just a different way we write it.
that's right, because molar mass is converting mass, grams, into moles, right? So that's why I get grams per mole. And AMU is just atomic mass unit. So if we're looking at something on a microscopic level, it's going to be AMU. If we're looking at something on a macroscopic level, such as we're doing it in the kitchen, it's grams per mole.
Grams per mole.
Okay.